Okay, it says solve for the point on the unit circle. Notice in the notes it's gigantic. I'm not going to do it so big. So they're talking about the unit circle, which is a circle with a radius of 1. So I'm going to put the 1 in the radius there. Now what if I draw a triangle and put a point on the unit circle and say that the x value is 1 over 4, and I'm wondering what the y value is? Well, we have an equation for the unit circle. X squared plus y squared equals, the formula for a circle is equal to r squared, and the radius is 1, and 1 squared is 1. So, excuse me, if I substitute in for x, the quarter value, 1/4, notice I use full-size fractions, equals 1. And I know that if I square that, I get 1 over 16 plus y squared, and I need to turn the 1 to have a lowest common denominator of 16, so I have to multiply the top by 16. And I'm going to subtract 1/16 from both sides. Therefore, y squared equals 15 over 16. Then I'm going to square root both sides of the equation, and I'm going to say y equals plus and minus. Now I can square at the top separately, 15 over 4. So I have a plus minus, but they've already told me that it's in quadrant 1. Therefore I have to have a positive y value, therefore I can just reject the negative, and I can circle my answer, find the y value. Therefore, the point is simply 1/4, comma 15 over 4. So, seen down below, I've done it with a point, with the x point. I used the same equation. I substituted in for y, and I solved for x, and x was negative when I square rooted both sides because it's in the negative quadrant. Further down below, there's notes on is the point on the unit circle, and you substitute x and y, and if the equation is true, it's on the circle, and if the equation is not true, it's obviously not on the circle. Okay, solve for p theta on the unit circle. So let's take a point on the unit circle. I'm going to draw the unit circle over here, and I'm going to draw a gigantic circle. We know that's the unit circle with a radius of 1. So I'm going to make a triangle in there, and I'm going to put a radius of 1. And let's say that I'm looking for this point with an angle of pi over 6. We can call this point p of theta, which equals p of pi over 6. And we want to know what that point is with respect to x and y. Well, I'm going to take that triangle off to the right, and I'm going to draw a little bit bigger. So let's take 1 pi over 6. Notice in the same orientation. And now I know that I have a special triangle with that angle pi over 6, but it's bigger, pi over 6, and has a hypotenuse of 2. And it has an opposite of 1 and a adjacent of root 3. And I know that this triangle is 1/2. So if I simply take 1 and I divide it by 1/2, I get 1/2. And if I take root 3 and divide it by 2, I get root 3 over 2. And then I can put those values into the diagram. So I have an x value of root 3 over 2 and a y value of 1/2. Which means that the point on the unit circle is simply open bracket, the x value, root 3 over 2, comma, the y value, 1 over 2. It also turns out that it's simply just cos of pi over 6, sine of pi over 6. Making that connection from before. So down below there's 2 more examples, one with a different special triangle, one simply just with logic, the unit circle, radius of 1, where your angles are 0 and 2 pi. Make sure if they give you a point on the unit, or a point on something, if they're not special triangles, then just use regular grade 8 similar triangles. Draw the triangle given in the shape, Draw another triangle off to the side, find the similarities between them, and answer the question.